Pre-calculus, chapter 1.6, exercises 21 through 32. This exercise set is on graphical transformations. I'm going to do the odd number problems in this set. In exercises 21 through 24, sketch the graphs of f, g, and h by hand. Support your answers with a grapher. So we're going to use the graphic calculator to verify. And for fx we have quantity x plus 2 squared. And so for this set here, 21, f, g, and h, we're going to be using the quadratic function, which is going to go like this. If you plug in -3, you get an output of 9, -2, 4, -1, 1, 0, 0, and then 1, 1, 2, 4, and 3, 9. So this would be the parent function. So all of these, f, g, and h, are going to be transformations. But this basic pattern here, this +1, +3, and +5, is going to be the basic pattern. And the same for the positive values, +1, +3, +5. So we have this first one, this x plus 2 squared, and if we take the parent function here, which I'm going to mark up like this, 1, 1, 2, 4, 3, 9, and symmetrically over here on the other side of the y-axis, and here we have, so we're going to have this sort of, this parabola here. I'm sketching through these points. Okay, so what we have here is this quantity x plus 2 squared. What is this x plus 2 going to do? Well, I happen to know that that's going to move the curve 2 units to the left. So the graph is going to look like this. And I'm going to verify using the calculator, and it so happens that I have pre-entered this function in the calculator, and I graph, and I get exactly that. The curve moved over 2 units to the left. Next we have this 3x squared minus 2. So what we're going to do for this is we're going to take this +1, +3, +5. We're going to have a different output altogether. What I'm going to do is leave these here, these values in place, and we're going to multiply each of these by another 3 to see what happens. So because we are vertically stretching by a factor of 3, so we have 9 times 3 is 27, 4 times 3 is 12, 1 times 3 is 3, then 0, then we have 3, 12, 27. So here we have a pattern of +3, +9, +15. And so we take, things going to look like this. I'm going to start at the origin again, but we have 0, 0, 1, 3, 2, 12, and so 2, 12 is going to be kind of off this thing right here. So there's 2, 12. I'm going to make these in red just for contrast's sake. Okay, 2, 12, and then symmetrically we're going on the other side of the y-axis. So we're going to have this looking curve here, very much steeper than for the last one we drew. So it's going to look something like this. And then we are also going to be translating downward 2 units. So we take this red curve here and translate down 1, 2 units. So we should see something like this, and I'm going to leave for contrast's sake the original translation of this blue one to see where that comes up. And again, I have pre-entered this function as well, so I go over to the equal sign, activate, and press graph. And I hope you can see that we have this vertically stretched parabola translated down 2 units. Okay, and now we're looking at this one, -2 times quantity x minus 3 squared. And for this one, we're going to have a reflected downward and stretched by a factor of 2. So for the one with to stretch by a factor of 2, what we're going to have is this. If we have x, y, and we're going to have, I'm going to put -2, -1, 0, 1, 2. And so we would have for -2, 4, but if we multiply that 4 by -2, we would get -8. Excuse me, -8 here. And then we would take for 1 times -2, so we would get -2, 0, -2, -8. So this is the pattern we should see for this -2, and this -3 is going to go to the right, x plus to the x minus to the right. So I'm going to go ahead and plot these points first. I'm going to do that in purple, and then we're going to translate over to the right. So we have 0, 0, we have -1, comma, -2, -2, comma, -8, and then we have +1, -2, +2, -8. So we're going to see this looking curve here. And we are going to afterwards translate this curve 3 units to the right. So we grab this curve here, move this 3 units to the right. 1, 2, 3, that looks like. I know it's kind of a rough looking curve, but that's sort of the best I could do on short notice. Let's go ahead to the calculator, and we go and activate our third function. So we go graph. This is what we get. Okay, so I hope you can see that that looks pretty similar to what was hand drawn. Actually, I probably should have drawn it wider here toward the top, but that's basically it. Now, next we're going to go to next on our problem, which is 23. And here we have a cube root function. The cube root, fx equals the cube root of quantity x plus 1. For the cube root function, I'm going to sketch basically what it is first of all. if we have a x, f of x, if we plug in a cube root of negative 8, we're going to get negative 2. If we plug in negative 1, we get negative 1. If we plug in 0, we get 0. The cube root of 1 is 1, and the cube root of positive 8 is 8. So this would be like a parent function pattern. And we're going to first translate this 1 unit to the left, because this is after the fashion of square root, cube root of x minus h, and h has to be negative 1 because we'd have x minus negative 1, so to get x plus 1, so we're going to shift to the left. So let's go ahead and sketch the curve in here. We have negative 8 comma negative 2, so here's negative 8 comma negative 2, negative 1 comma negative 1, and we 0 0, and then 1 1, and 8 2. So this is what our curve is going to look like. This, I want to do it all in one stroke so I can translate it easier. Okay. So it'll look something like this. Okay, I hope that all stays together. So there it is, and we're going to translate 1 unit to the left. I hope it's all hooked in there. No, it didn't. It kind of, so I'm going to piece it here. 1 unit to the left. So there's 1 unit to the left. I'm going to get this second piece over here. So the thing is going to look something like this. And let's go to the calculator. And I'm going to go ahead and deactivate these first 3 and go to this 4th one and activate the 4th one. This should be magenta, should be 1 unit to the left. And there it is. Okay, just like graphed. Next, let's go to G, which is 2 times cube root of x minus 2. And what I'm going to do here is I'm going to add another column for g of x, and I'm just going to multiply by a factor of 2, and that's going to take this negative 2 to be negative 4. Negative 1 is going to be negative 2. Then we have 0, 2, and 4. And then when we go ahead and we're going to have negative, we're going to actually translate down 1 unit 2. So we're going to subtract another 2, subtract another 2. So when we go ahead and put all these together, we'll get here negative 6, negative 4, negative 2, 2 minus 2 is going to be 0, 4 minus 2 is going to be 2. So what this is going to look like is, I'm going to do this in red, we're going to have negative 8 comma negative 6. So I'll go to negative 8 comma negative 3, 4, 5, 6. There we go. We're going to have negative 1 comma negative 4. We're going to have 0, negative 2. We're going to have 1, 0. And finally, we're going to have 8, 2. So we go to 8, 2. So our curve should be something like this. So it looks like it's gonna run up against our original blue one we have here. And getting to our calculator, that's going to be a green one according to the coloring there in our TI-84 CE graphic calculator. See, just matches just fine. Okay, checked out 100% with the grapher. Lastly, we have this negative cube root of x minus 3, and I'm going to go over here to the right and show what that looks like. We're going to have x h of x, and for that we're going to have, what I'm going to do is translate this negative 3 is going to translate 3 to the right, but I'm going to translate that later. But we're going to take the negative, so I'm going to put 0, negative 1, negative 2, and 1 and 2, and no, I don't want to do that. I want to do the 8. So I have to keep track of it. Here we go. Negative 8, negative 1, oh excuse me, that's positive 1. Okay, positive 1, 8. And we're going to take the negative of what that is. And so we're just going to, so instead of negative 8, comma, negative 2, that's going to be negative 8, comma 2, negative 1, comma 1, 0, comma 0, 1, comma negative 1, 8, comma negative 2. So what that is going to look like is this. We go to negative 8, comma 2, so we go to negative 8, 2, negative 1, 1, 0, 0, 1, negative 1, and finally 8, negative 2. And once we do that, we're going to go like this. More or less. Okay, and we're going to be shifting. This minus 3 will move to the right 3 units. So I'm going to take this 3 to the right. 1, 2, 3. So we should have an x-intercept at x equals 3. So again, we go to the calculator, y equals, go down and activate function 6, which should be in orange, looks like, and see if we are turned upside down and shifted 3 units to the right. There we go. It's just like the magenta one, but turned upside down, shifted 3 units to the right. Check. Okay, so there we have it. Next on our problem, I'm going to go to 25. Next exercise 25 through 28, the graph is that of a function y equals fx that can be obtained by transforming the graph of y equals square root of x. Write a formula for the function f. Well, I have a hard time seeing everything here, but basically for the function y equals f of x, we're going to have a standard parent function. If we go to x, f of x, we input 0, we'll get square root of 0, which is 0. If we plug in 1, we get square root of 1, which is 1. If we plug in 4, we get square root of 4, which is 2. If we plug in 9, we get square root of 9, which is 3. So what we should see is this. I'm just going to, we have 0, 0, 1, 1, 4, 2, and finally 9, 3. So something like this. But we are shifting 1, 2, 3, 4, 5 to the left, and let's see what this looks like. 1, 2, 3, 4, 5. So pretty well matching. And so the best I can gather from this, we're going to have, says f of x, okay, for f. So we'll say f of x is equal to square root of x, and what do we do to shift 5 units to the left? We're going to add 5. So that's what it should be. And what I'm going to do is graph this in the calculator and see if our x-intercept matches. Should be, our y-intercept matches. A little over 2 is what it should be. And I think that should be right, because if we shift 5 to the left, if we shifted 4 to the left, we would have exactly 2. But shifting 5 to the left, we're going to come up a little more than that. So yeah, that's what we should expect to see, but to be for sure. I'm going to come up here and I'm going to deactivate this one, and this one, and go up. I'm going to go up to the top and put square root of quantity x plus 5. And graph the function. I think that's the only one we have highlighted. Yeah, you should see, right? It comes right. The y-intercept is a little over 2. So that's going to match really well. So this is going to be our correct answer. Okay, next, 27. We have another square root function. This time we have one that's turned, that's reflected about the x-axis, and it looks like this is going to be like 2 units to the left, and it's going to be over here plus 3. So what we're going to do, and then plus, we have the reflection upside down. So I'm going to surmise that we're going to have f of x is equal to negative square root of x, and we moved 2 units to the left, so I'm going to put plus 2, and outside we moved up 3, so I'm going to put plus 3. So we should get something like this. And of course, I don't have everything marked in here super well, but let's just give it a try. So clear negative square root of x plus 2, and come out here and say plus 3. Hope this works out. Graph. So there's where the thing starts. Looks like our y-intercept is between 1 and 2. Our x-intercept is down here at 1, 2, 3, 4, 5, 6 roughly. 6 or 7. Okay, between 1 and 2, 6 and 7. So that's between 1 and 2, and 1, 2, 3, 4, 5, 7. Yeah, so it checks out pretty well. So as far as I can tell, this will be a pretty good answer. Okay, next other problem. We're going to, this 28 looks like it's a vertically stretched version. In fact, they do tell you that here. they tell you at the bottom the vertical stretch is 2. So that should be easier to do given that clue. 29. Find the equation of the reflection of f across the x-axis and b the y-axis. So here we have an original function, and for a reflection about the x-axis, we're going to say, I'm going to make this g of x. G of x is going to be equal to, multiply the whole thing by negative. So we're going to have negative x cubed minus 5x squared minus 3x plus 2, and just distribute the negative sign. So we have negative x cubed plus 5x squared. This will be plus 3x minus 2. And so if we plug this in, we should have a the vertical reflection, or across the x-axis. So this would be for part A. For B, what we're going to do is we'll say h of x is equal to, what we do is we take the original function, and every place there's an x, we put negative x. We'll get negative x cubed minus 5 times parentheses negative x squared minus 3 times negative x in the place of this x, and then we just have plus 2. And simplifying, we're going to have negative x cubed, and we're going to have minus 5x squared, and then we're going to have minus minus, so we'll have plus 3x, and finally we'll have plus 2. So that's going to be h of x. Now I think what I did is I pre-programmed the original and b. So let's take a look at those. I'm going to enter. Okay, so let's go here. We'll diminish that function. Come down here. So this one here in red, that's our original function. We graph. So that's what it looks like. And the one right next to it is going to be this one is going to be reflected about the y-axis. So let's graph that. And can you see how this blue one is the reflection of the red one about the y-axis? And finally, I want to go down and do a reflection about the x-axis, and I'm just going to turn this red one up here above to negative. Everything that's negative is going to be positive. Everything that's positive is going to be negative. So we have x to the third power, and then we're going to have plus 5x squared, and then we're going to have plus 3x, and finally we're going to have minus 2. So all these reverse signs here between y7 and y9. We should see the one turned upside down about the x-axis. Let's graph. And so that's a little, let me go ahead and so it's this one. I'm going to go ahead and get the blue one out of there just to ease the distraction. There we go. The blue one's gone now. Let's graph the original and now reflected about the x-axis. See that pattern? Reflected about the x-axis. So these will check out, both of them. So A and B. Here's the answer to A. Here's the answer to B. Now the last one I'm going to do in this video lesson is number 31. We have the cube root of 8x, and so for A, reflected about the x-axis, we're going to have g of x is equal to negative cube root of 8x. And for B, we're going to have h of x, we'll say, is equal to cube root of, we're going to have 3, and we're going to have negative 8x here inside. And I'm not sure how the distribution is going to fix things of these, so I just want to see what they look like. Going to the calculator, let's go here, clear, we're going to have cube root of 8x, that's 4, 8x, and when we graph this function, I think that's the only one, is the only one that's highlighted at this point? No, I got to get rid of these two here, y9 and y7. So there it is, that's the cube root function. And to turn this upside down, the y-axis, but the x-axis, we'll put negative cube root of 8x. So we have this looking thing here. See, that's going to reflect about the x-axis. Now we're going to reflect this about the y-axis. We're going to take this negative sign here and delete that and put the negative sign inside. So I'll make this negative 8x. And so we graph here, and I hope you can see that reflected about the y-axis in this case does the same thing as reflecting about the x-axis in effect. So we end up with what ends up to be the same graph in both instances. But these are our correct answers here. And as far as the book goes, let's see, 32. Okay, here's 32. Anyway, I'm presuming perhaps better understanding than an average pre-calculus student does, but with a calculator in hand to check and gradually work your way through these things should be feasible. I hope this has been helpful to you. Good luck, and thanks for viewing.